And now we're going to actually build this calculator. In my book, I showed all the solutions that I used to do it. The first one is just a rough one, just getting the job done. And then after that, there is a lot of I think 2 or 3 times there's refactoring, which is rewriting your code to make it better. And it also makes use of Clippy. And Clippy is a great tool for telling you when your code works, but maybe is not the best method. It'll say, hey, you're allocating data when you didn't need to, or you're typing too much. You didn't need to do that. And so there's going to be some refactoring. And so first, I'll just show you the first solution, and then there's going to be changes made after that. So the first thing to do is to this math function, because right now it's returning a 6, and that's not good. So we're going to actually do some math. So the first thing to do is so we have a string, a str, and so we want the user to be able to write spaces, because people always write spaces, but we don't need them. And then another thing we want to do is ignore all the signs after. So 7 plus 10 plus 40. So it should be able to accept this, because these are all okay characters, but it should cut this all off, because there's no number following it. So we're going to do that. So and this is the input. So we'll just shadow it and say, okay, the input is now going to be input dot, and there's something called trim end matches. So that is going to it trims a str as long as it matches something. So that's the if there's like all these minuses at the end, then it's going to get rid of those. So input dot trim and matches, like that. We'll just call this X, and we're going to say, so we want to get rid of all the pluses and minuses at the end, and we just say, so if it contains X, then get rid of that, and so that'll just get rid of it. And then so now that it's gone, we're going to take chars, turn it into characters, and then we're going to filter. I'm going to put that down here, like that. And filters, keep everything that is, depending on the expression you give it. So we're going to say, if X is not equal to a space, then keep it. So that'll get rid of all the spaces. And then we're going to collect it into a string like that. So this will give us a single string with nothing else, no weirdness. So let's just whoops, that's not main. Let's go to main. We can do a little bit of print line debugging as well. So let's return a 6, like that. Let's just print it there. So input. So let's give this a try. So math, we're going to say 7 plus this, and we're going to do, what else are we going to do? 1 minus 2, 1 minus 1, like that. So it should, now we're going to run it instead of testing it. And it should, there you go. So you can see the spaces are gone, and so are all the pluses and minuses. And but if we do this, this is gone too, because these are spaces. So that's fine. And now we can get rid of that, because we're going to try to rely on our tests instead. So let's take out the print line. And so the next thing I did was, so first we have let's have this thing called a result vec. Put results in there. What are they going to be? We'll find out later. And then we're going to have something, I came up with something called a push string. and string.new, and this is going to be so let's say you have some numbers here like 7 plus, so this is the what's going to come in now, minus 10, and it's going to kind of go through so we're going to look at what the signs are and what the numbers are, and depending on that is going to push something into the string and then use it to parse and then make a number. And at the same time, this minus is going to be there's going to be like a adds sort of thing, so that'll be like a boolean. So if you see a minus, then it'll become false, and if you see another one, it becomes true, like that. And on the other end are plus actually doesn't mean anything, because plus doesn't change the sign at all. So if you have 7 plus 8 plus 10, that's basically just 7, 8, and 10. So that is sort of the logic there. The next thing we'll do is okay, we're going to have a so we got this input here. So it should be for character in input.chars, and so it should be a whole bunch of, it should be one of a number of things. So if it's plus, we're going to do something, not sure yet. If it's a minus, we should do something, and then if it's anything else, it should be something, and the only anything else left is going to be a number. So going to just call that number, because that is the the catch all. So instead of doing this, we're going to say anything that's not this and is not this is going to be a number, and we're going to do this when we have a number. And let's get back to 6 because video's getting long. Let's see. For character, oh right, match character. Match character. That's what's missing. So let's do that again. Just make sure that input, and that should be a dot. And I think it's going to work now. Type annotations needed for vec. That's true. Comment that out for the moment. And okay, so everything is still, it's running again. We'll give it a quick format, and you can see the logic is starting to come together. We are parsing this. We've got this results vec. We're going to do something with it. This is going to, oh, by the way, there's a method on strings as well called clear. That's the reason for this. So you can add things to a string, push it. It's basically like a string is actually a vec of U8s. Just the one final thing to look at before we end the video. If you go to string and you go to the source there, you can see, a string is literally a vec of U8s. U8s are used for bytes, so that's why they act like vec so much, and that so that gives you methods like clear, and this string is going to be used to put stuff in and then clear it out, and it'll function a lot like vec.